Potatoes, or the biggest problem in application programming. Preface. Everything I talk about here is inspired by the CouchDB database. It is a document-oriented database. It means it stores objects. It inspired a client-side program called PouchDB, which also works really well. And CouchDB was inspired by really wise ideas, by really good ideas that must have come out of years and years of programming. I don't know much about its history or its inventors, but the ideas are impeccable. And if you just take a moment to ask yourself, why the heck is there a revision number? And why is the revision number followed by a random number? It all eventually makes sense. The best way to understand potato collections is to use PouchDB and CouchDB and compatible services. But I think eventually we will all end up creating our own version of it all. And this is roughly what this text is about. The biggest problem is synchronizing information on your computer network with the information displayed on your customers' screens. Oh. By synchronizing, I mean constant updates. If you, as administrator, change something, it needs to change on all the affected application screens, live, instantly, efficiently, wisely, and smartly. Nerds may argue with me that the biggest problem is the general purpose strong artificial intelligence, but we are talking about real problems that business owners fighting poverty face every day. Others may check me here and mention security, but security problems exist out of greed. If you just let your user own their database, there will be nothing to hack on the application level. The changes to the network data come from an application that can uniformly access all the databases. I'm talking about administrative changes. The application lives on the network, though, and cannot be run from the web, not without enhanced security. Enough of that. Let me tell you how to get things going. And here, I must intrude the concept of a potato. Instead of coming up with fancy names, let us come up with something interesting. The unit of information on our network is a potato. Our potatoes are inspired by CouchDB documents and the beans of the Java programming language. They call them beans so they can say Java beans. Whatever. We just have plain potatoes because we want to keep things simple and underline the fact that we don't program computers, but really, realistically, at the end of a busy day, take what we can get. In programming languages, we have numbers and strings of letters, strings for short, text. We can group numbers and strings into objects, and we can put objects inside objects. But our potato here is special because we treat potatoes as highest order objects. There is nothing above them. Potato is king. And potatoes must not hold other potatoes. A potato is just the highest level object in this abstraction that we are creating here. It can only have generic objects nested inside it, but never a potato. That means when you create a user on your system, you make a potato and give it a username property and a password and all that. When you create a new post for a user's blog, it is a potato with username and text properties. It can have many properties, like 100 even, and other objects inside it with other strings and numbers and objects, but never a potato. We want to keep things simple, linear, really. Exactly like the CouchDB document, a potato has a universally unique ID and a revision number that is yet again followed by another unique ID, so that multiple people that send in the same revision can still be saved on the system. The revision ID is the file name that is used to store information on a hard drive. The document ID is used for the directory that contains all the document revisions. If you have 1 million users saving all at the same time, say to revision number 15, you will just end up with 1 million randomly named files inside the directory, prefixed by number 15. No data is lost. All conflicting revisions get saved. It is very simple to write a program that will merge all the millions of revisions into a winner, for example. But it all depends on what you use the potato for. There's one important point that you have to remember. When picking the winning revision, you sort the random file names and pick the one that comes out on top. This is a stupid way of picking the winner. It completely ignores the potato content. But it is also really cool because no matter how many conflicting revisions you have or how many of those are still being uploaded to your server, how many of those are in the Ethernet cables, you will always have a clear winner. And eventually, as all the files make it into your network or into the user's browser, you will pick the same winner, always the same winner, the one that is up on top when you sort alphanumerically. Nerds call this eventual consistency, but it's just sort and then taking the top array item. I want to repeat that the potato is inspired by CouchDB, and you should use PouchDB and CouchDB at first to get a feel for it, for the potatoes, for the ways of doing things, for the importance of the ID and the revision. But you know how things go. As your software becomes more and more advanced, as your needs become more and more complex, and as your ideas become even more brilliant, you will eventually need to go potato. Eventual consistency, be it on your network or inside an array in your user's browser, means that users have their account data synchronized with their browsers all the time. It just works. All the conflicts resolve themselves. But it also means that the network will continue bubbling up new revisions of all kinds of potatoes or CouchDB documents. Your user interface components must be notified of the new potato revisions, or more precisely, revision winners, the ones that come up on top in the sort algorithm. Here, you have to keep things simple, so use Svelte, at least for now, and Svelte stores. A Svelte store is an event emitter-based pattern for notifying the application of changes. So it's a trustworthy and simple little program. From here, focus on creating collections or arrays of potatoes. A collection is just a spicy array. It's an array with extra functions that you may find useful. Sometimes you might just want to have a collection that is always just one potato. For example, user profile. It's pretty cool to just represent it with a simple potato. This way you just keep everything in one place. Here, if at some point in the future you start offering complex services, you can just throw another potato in that collection. Perhaps one for custom domain names, one for web hosting configuration. You're going to have 3 potatoes as a little menu on the side, and whichever the one user clicks on, you just render it with the user interface components. And here, at least for now, I recommend using the Bootstrap CSS framework. Because everything is constantly changing, you have to consider unusual use cases. If your user is browsing a list of products, for example, and they are on page 10 of 10, and you decide to remove most products to sell something more integrated, there will be no longer a page 10. You may only have 3 pages now. So you have to yank them back to the last page. You can say, the current page equals the new last page. Keeping things consistent in lists, even if you just have one thing, will pay off to account for all these complexities. Because potatoes have an ID that is independent of whatever you are storing in them, to save something, you just send it to the server with its ID. And the server will send it everywhere else, including back to you, as a new change during live synchronization. And the way you would synchronize files across servers in your network is just rsync. It's just a standard Unix command. Very cool stuff. There's nothing to hack here. The most confusing thing is the lists of potatoes in the application user interface. The collection that your application uses to create all the different UI hierarchies. But you know that potatoes are there and that they are simple. You're always comparing IDs, and whatever new potatoes found, you send the latest revisions out everywhere, and so on and so forth. And it all sorts itself out. A new ID means new potato. A new revision means you have to reselect a winner. Svelte will automatically update your user interface, and all your buttons worry about is just sending documents into your network, or potatoes into your network, with their correct ID. PouchDB and CouchDB also reveal a really good pattern for fast searches. Roughly, each time a new document change is announced, little programs called views check if those new changes match the information that they are filtering for. This is how your potato collection is assembled. You remember the potato ID that matches and forget the one that does not. And yeah, you don't have to rely on Svelte. It's possible to eliminate most things here. In the case of Svelte, you just use a standard DOM reconciler that will merge your document object nodes all proper. While I highly recommend using Pouch and Couch and compatible services for data storage, eventually I think it may just be easier to write a custom potato storage system, just like you write a custom user interface component for whatever new application idea you come up with. Document IDs and random revision file names allow for multi-core or CPU data storage. Nothing is ever overwritten with universally unique identifiers. Really cool stuff. Nothing is ever overwritten on your network because everything has a unique file name. Nor is there a problem when saving to a file during simultaneous processing, because the revision, whatever number it is always guaranteed to be followed by a universally unique identifier.